Hello and welcome to this video lesson. This video lesson will focus on whether a point lies on a function. Let's start with a quick review from the past lessons. If we are looking at an equation of a line, here we have y is equal to mx plus b. The y and the x are the y and x coordinates of the line, so I will write that down here. So this is the y coordinates. The x is the x coordinates of any points in the line. So these are x and y coordinates of any points in the line. The m value over here is the slope, and the b value can help us figure out where the y-intercept is. So if I have a line similar to this line over here, you can see that this line's slope never actually changes. So this slope value is always the same for this line. The y-intercept is always here for this particular line, so this value never changes. So m and b values are always the same, but the x and y values can always change because this equation is used to map out all the coordinates of the points that lie within this line. So this, for example, we have this point over here, which is x1, y1. So if I were to put x1 into my x value over here, or my x coordinate, it should give me the corresponding y value over here, so y1. And if I were to do the opposite, if I were to put the y1 coordinate of, or y coordinate of this point over here, then if I solve for x, I should get the x coordinate, which is exactly this x value over here. And again, a line will have infinite number of points, so you can choose any x value for your point and find the corresponding y value with this equation. Alright, let's try this example. The example says, do points 2, 11 and negative 3, 3 lie on the line with equation y is equal to 3x plus 5. So we're just testing over here to see if this point over here can be on this line, or can this point over here be on the line. So we know that in this equation over here, we have the y coordinates, the slope, the x coordinate, and the y-intercept. So I know that the value 3 and 5 will never change, and I can use any x value to figure out what the corresponding y value is for an individual point. So what I can do, let's start with point 211. For point 211, x coordinates is 2. So if I use my equation y is equal to 3x plus 5, I can actually plug in my x coordinate, 3 times 2 plus 5, and I can see that if I do that, my y coordinate will end up being 3 times 2, which is 6, plus 5, so y will end up being 11. So I can see that if the x coordinate is 2 for this line, the y coordinates of the points on that line will end up being 11. So since when x coordinates is 2, y coordinates is 11, therefore point 211 lies on y is equal to 3x plus 5. So to summarize, what we've done is we plugged in the x coordinate of our point into our equation, and our equation has outputted a y coordinates, and in this case the y coordinate was 11, meaning that when the x value on this particular line, or x coordinate of a point on this line, has a value of 2, its y coordinate will be 11, which matches with this point over here, meaning that this point lies on this line. If we had gotten a different y value, it would mean that when the x value, or the x coordinate of a point on this line is 2, the y value will be something other than 11, which would mean that it wouldn't match with this point, and thus this point would have not lied on this line. So let's try the second example where we have our point as -3 and 3. Okay, so now for points -3, 3, we know that the x coordinate is -3. So the x coordinate always corresponds with this first value. So what we're going to do is we're going to plug in -3 into our x coordinate of this equation and see that what is the y coordinate of the point that lies on this line. And if it's 3, that means it matches with this, meaning that this point is on the line. If it's a different value, if any values other than 3, we know that this point does not lie in here. So let's try that on. So y is equal to 3 multiplied by -3 plus 5. 3 times -3 is -9, plus 5 will give us a value of -4. So this means that our point on the line is actually -3, -4. And since -3, -4 is not -3, 3, therefore that point -3, 3 does not lie on y is equal to 3x plus 5. So what we've done is we've taken the -3, which is the x coordinate of this point, plugged it into our equation to see what is the y coordinate of the point that actually lies on the line, and we figured out that the point that actually lies on the line is -3, -4, and not -3, 3, and thus this point over here does not lie on this line. An alternative method would be to use the y coordinate and test if the x coordinate would be the same. So for point -3, 3, y coordinates is 3. So we can plug the y value into our equation. So 3 is equal to 3x plus 5. And we can try figuring out the x coordinate of the point on our graph, which has y value of 3, or y coordinate of 3. And if this x value ended up being -3, that means that this point lies on this line. But if it doesn't, that means it doesn't. So let's solve for x here. So first thing I have to do is I have to subtract 5 from both sides. So I get -2 is equal to 3x. I will then have to divide both sides by 3 to get x on its own, and I get x is equal to -2 over 3. So that corresponds to a point -2 over 3 and 3 on our line. So on this line, when the y coordinate is +3, then the x coordinate ends up being -2 over 3. definitely not negative 3, meaning that since negative 2 over 3 is not the same point as negative 3, therefore the point negative 3 does not lie on y is equal to 3x plus 5.